knows a lot about the science stuff. Professor Dave explains.
Okay, let's try a question about Hess's law. So, given the thermochemical data below, those are the three reactions at the bottom, we want to find the change in enthalpy for the following reaction. So we have ClF plus F2 yields ClF3, and that delta H value is unknown. But we have three somewhat related equations at the bottom with known thermochemical data. See how we have those delta H's there. So we can use a technique called Hess's law to solve this problem. And if you're unfamiliar, go ahead and check out my tutorial on Hess's law. That will explain everything you need to know to solve this problem. And when you're ready, give it a try. Okay, so up top we have what we need to figure out, and then on the bottom we have all of our given data. That's the stuff that we can use. That's what we can work with and manipulate in order to get the delta H that we want. So where are we going to start? Let's start out by looking at what we need in our given equation and then finding where those substances are in the given equations. So we know we need ClF. We need ClF. We need to find where that is in these equations down here. Well, the second equation has 2 ClF. So there's that whole equation, but it has ClF in it. That's the only place we have it. So we know we need to use this equation. The problem is we have 2 ClF. We only want 1 ClF. So what should we do? Well, what we can do is we can cut it in half. We're going to cut it in half, meaning we can cut the stoichiometric coefficients in half, and we will therefore also cut the delta H value in half. So we've done this here. 2 ClF becomes ClF, O2 becomes 1/2 O2, Cl2O becomes 1/2 Cl2O, and OF2 becomes 1/2 OF2. Now we mustn't forget to cut that delta H in half as well, because we're cutting all the stoichiometric coefficients in half. That means the delta H will be half as much as well. So 205.6 becomes 102.8. Now, what's next? We need F2. We need F2 as a reactant. So where's F2? Well, over here, we have 2F2, and we have it as a product. And that's the only place F2 is, so we know we need to use this equation. So what are we going to do? We need F2 as a reactant, but here we have 2F2 as a product. So what we need to do is we need to take this first reaction, we have to flip it so that the products become reactants and the reactants become the products. And we also have to cut it in half. So we have to do 2 manipulations here. So let's do that. Products become the reactants. So O2 as a product becomes 1/2 O2 as a reactant. And then 2F2 as a product becomes F2 as a reactant. And then 2OF2 as a reactant becomes 1OF2 as a product. So we have flipped it and we have cut it in half. And then don't forget, we have to also manipulate the delta H value in the corresponding way. So when we flip it, whenever we make the products the reactants and the reactants the products, all we have to do is flip the sign. So we took our negative 49.4 and we made it positive 49.4, but we also cut everything in half. So from positive 49.4, we went down to positive 24.7. So that is the delta H value for this reaction. And lastly, we need ClF3 and we need it as a product. So where can we find it here? Well, this third reaction has ClF3, but it has it as a reactant. So what can we do? All we have to do is flip the third reaction. So let's do that now. So 1/2 Cl2O as a product becomes a reactant. 3/2 OF2 becomes a reactant. And then ClF3, which was a reactant, is now a product. And O2 is also now a product. And once again, we can't forget, we have to take our delta H value. It was positive 266.7. Because we flipped it, it is now negative 266.7 kilojoules. So we've got everything we need. So let's just check and make sure what cancels out. Let's make sure everything that we don't want in there is going to cancel out. So what do we have? Well, on the left, we have a half O2 in the first reaction. We have a half O2 in the second reaction. Those are both reactants. And then we have 1 O2 as a product in the third reaction. So half and half makes 1, and then we have 1 on the right. So O2s all cancel out. Then we have 1/2 Cl2O as a product in the first reaction, and we have 1/2 Cl2O as a reactant in the third reaction. So those will also cancel out nicely. Then on the right, we have 1/2 OF2 in the first reaction. We have 1 OF2 in the second reaction. And then in the third reaction, we have 3/2 OF2 as a reactant. So 3/2 OF2 total as products and 3/2 as reactants. And so those will also cancel nicely. And what are we left with? We are left with just what we wanted. We've got CLF, we've got F2, and we've got CLF3. So that is what we wanted. We do end up with the reaction as listed at the top. So all we have to do is now add up the corresponding enthalpy data. And so for the first one, we've got 102.8. For the second one, we've got 24.7. And for the third one, we've got negative 266.7. So we put those in the calculator, add them up, and we end up with negative 139.2 kilojoules. That will be the delta H for the reaction in question.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.